Good day everyone. So in this video, I'm going to solve one problem in statics of rigid bodies. So here it goes. The thrust shown below is supported on rulers at A and hinge at B. Solve for the components of the reactions. So we are required to solve the reaction at A and B. So in this thrust, we have joint C, A, F, B, E, and D. It has loads acting at C, which is 400 pounds, at D, which is 240 pounds, and at E, which is 600 pounds. It also has measurement and feet. From joint C to A is 12 feet, A to F is 12 feet, F to B is 12 feet, so in total, C to B is 36 feet. From joint D to A is 16 feet, and from joint E to F is also 16 feet. So now, we're going to determine the reaction at point A and point B. At joint A, it is supported by a ruler, and a ruler has only one reaction, which is perpendicular to the surface in contact. And now we have AY, which goes upward, assuming that it supports some loads that goes downward to maintain equilibrium. As you can see, AY is perpendicular to the surface in contact. And at B, it is supported by a hinge, which means it has two reactions, the X and Y components. And now we have BX, assuming it goes to the left, and BY, assuming it goes upward. So now, we're ready to solve the components of the reactions, which are AY, BY, and BX. Solve for Bx because along the x-axis we have two values, which is Bx and 240 pounds. With one unknown, which is Bx, we can solve for Bx. So to solve for Bx, we're going to use summation of all forces along x-axis is equal to 0 to the right positive. So we have 240 pounds going to the right is positive Bx. Going to the left is negative. Negative Bx is equal to 0. So getting the value of Bx, we just need to transpose it to the other side. So we have Bx is equal to 200 pounds. So now we're left with two unknowns, Ay and By. Using the summation of forces along the y-axis is not suitable for now, because the two unknowns are along the y-axis. So we're going to use the summation of moment. So summation of moment at point B is equal to 0 clockwise positive. So we're using B as the reference point for By to be 0. And with that, we can get the value of Ay using the summation of moment at point B. So we have 600 pounds going downward and going at B in a counterclockwise direction, it will be negative. We have negative 600 pounds with a moment arm of 12. And we have 240 pounds going to the right in a clockwise direction at point B is positive. with a moment arm of 16. And we have AY going upward in a clockwise direction at point B is positive. So we have positive AY with a moment arm of 24. And we have 400 pounds going downward in a clockwise direction at point B is negative. With a moment arm of 36 feet is equal to 0. By getting the value of AY, we just need to transpose all the known values to the other side. So AY is equal to 740 pounds. Now that we have value for AY, we can use the summation of forces along Y to get the value of BY. So summation of forces along Y is equal to 0 going upward direction is positive. So along the y-axis, we have 600 going downward means negative 600. 600 pounds. And 400 going downward means negative 400 pounds. And AY going upward is positive AY. And BY going upward is positive BY is equal to 0. Since the value of AY is already known, we just need to substitute the value of AY to the equation. By getting the value of BY, we just need to transpose all the known values to the other side. So we have BY is equal to 260 pounds. So now we are finished for solving the components of the reaction, which is Bx is equal to 200 pounds, AY is equal to 740 pounds, and BY is equal to 260 pounds.